Hello everyone, welcome back to Oddology, where reality is often stranger than fiction. Humans spend decades scanning the skies, listening for signals, searching for life beyond Earth. Yet right here, on this planet, there are creatures so bizarre, so illogical, that if you saw them without context, you'd assume they were alien. Today, we're diving into 5 animals that genuinely make no sense. And yet, they exist. Let's begin with something that looks simple at first glance, but completely breaks the definition of what an animal even is. The Portuguese man-o-war is often mistaken for a jellyfish, but that assumption is fundamentally wrong. It is not a single organism. It is a colony. A floating alliance of hundreds, sometimes thousands, of genetically identical individuals known as zooids. Each zooid is specialized, meaning none of them can survive alone. Together, they function as one. At the top sits the pneumatophore, a gas-filled bladder that acts as both a float and a sail, allowing the colony to drift across the ocean surface. This structure can reach up to 30 centimeters long and rise about 15 centimeters above the water. Interestingly, it contains not just air, but also carbon monoxide produced by the organism itself. Beneath it hang the dactylozoids, long, venomous tentacles that can stretch up to 30 meters in length, roughly the height of a 10-story building. These tentacles are lined with nematocysts, microscopic harpoons that inject venom capable of paralyzing fish instantly and causing extreme pain, or worse, in humans. Once prey is captured, it is passed to the gastrozoids, which handle digestion by secreting enzymes and breaking the prey down. Then there are the gonozoids, responsible for reproduction, forming complex reproductive structures that can detach and function independently in the water. But here's where things get even more fascinating. These colonies are not entirely at the mercy of the wind. Some individuals are left-handed, others right-handed, meaning their sails are angled differently. As a result, half of them drift slightly left of the wind direction, and the other half drift right. This reduces the chance that an entire population will be wiped out if currents push them toward shore. It's not intelligence, but it's an evolutionary strategy that feels eerily calculated. Now imagine something that hunts this creature. Meet Glaucus atlanticus, also known as the blue dragon. At only about 3 centimeters long, it seems insignificant, almost fragile. But it is one of the most efficient examples of biological weaponization in nature. Instead of producing its own venom, it steals it. The blue dragon preys on venomous organisms like the Portuguese man-o-war, carefully consuming them and isolating their most potent stinging cells. It then stores these cells inside its serrata, finger-like appendages that extend from its body. Over time, it concentrates the venom, making its own sting potentially more powerful than the creature it consumed. Even its movement is unusual. It doesn't actively swim long distances. Instead, it relies on a gas-filled sac in its stomach and the surface tension of water to float upside down, drifting along with ocean currents. This inverted position leads to one of the most fascinating camouflage systems in the animal kingdom. Its blue side faces downward, blending with the ocean depths when seen from above, while its silver-gray side faces upward, blending with the bright sky when seen from below. It is perfectly hidden, from both directions. And then there's the detail that almost feels unnecessary, but real. During feeding, gas can escape from its stomach, producing small popping sounds. It's a reminder that even the most elegant designs in nature can be awkward. From something tiny, let's scale up to something massive and equally strange. The Japanese spider crab looks like it crawled straight out of a nightmare. With a leg span reaching up to 3.7 meters, it holds the record for the longest legs of any arthropod on Earth. Its body alone can weigh up to 19 kilograms, making it one of the heaviest crustaceans alive. But despite its intimidating appearance, it is not an aggressive predator. It is a scavenger, moving slowly across the ocean floor at depths of up to 600 meters, feeding on dead animals, plant matter, and anything it can manage to catch. Its long legs allow it to cover more ground efficiently, but they come at a cost. These limbs are fragile, often breaking during encounters with predators or getting tangled in fishing nets. In fact, studies suggest that up to 75% of individuals are missing at least one limb. Fortunately, they can regenerate lost limbs during molting. And like many crustaceans, they never truly stop growing. In theory, given enough time and ideal conditions, they could continue increasing in size indefinitely. Some estimates suggest they can live up to 100 years, though in the wild, survival rates are much lower. Now let's talk about something that appears harmless, but is anything but. The slow loris is often described as one of the cutest animals on Earth. Large, round eyes, small hands, slow movements. It looks almost designed to trigger a protective response in humans. But hidden behind that appearance is one of the most unusual defense mechanisms among mammals. The slow loris is the only known venomous primate. It produces toxins from a gland located near its elbow. When threatened, it raises its arms, licks the gland, and mixes the secretion with its saliva. When it bites, the venom is delivered through specialized teeth that act almost like channels, allowing the toxin to enter the wound efficiently. The effects can be severe. In humans, bites can trigger anaphylactic shock, which in extreme cases can be fatal. But what makes this even more disturbing is that slow lorises are not immune to their own venom. Studies have shown that around 20% of individuals carry wounds caused by venomous bites from others of their species. In some populations, more than half of adult males show evidence of such injuries. They also use their venom defensively by grooming it into their fur, effectively turning themselves into a toxic surface. For predators, even touching them can be dangerous. And finally, we arrive at something that looks like a mistake, but is actually precision evolution. The okapi. At first glance, it looks like a hybrid between a zebra and a deer. Its striped hind legs stand out dramatically, making it appear anything but hidden. But appearances are deceiving. The okapi is most closely related to the giraffe, sharing structural similarities despite its very different look. It lives deep within the dense rainforests of the Democratic Republic of Congo, where light barely penetrates the canopy. In this environment, vision works differently. Predators like leopards rely more on contrast than color. The black and white stripes on the okapi's legs disrupt its outline, blending with the fragmented light patterns of the forest. What looks obvious to us becomes nearly invisible to them. Some researchers also believe these stripes function as a guidance system for calves, helping them follow their mothers through dense vegetation. Each pattern is unique, much like a fingerprint, ensuring accurate recognition.
Nice.
5 creatures, 5 completely different evolutionary solutions, and yet all of them share one unsettling truth. They don't look like they belong here, but they do. And maybe that's the most important takeaway. If life on Earth can evolve into forms this strange, this complex, this illogical, then the idea of alien life might not be as distant or as unimaginable as we think. Because perhaps We've been surrounded by aliens all along. This is Oddology. Stay curious, and I'll see you in the next one.